Good afternoon. Factory of the future. A lot of talk is done about this subject and a lot of research is also done. In this short talk, I will just introduce some concept about the restructuring of EU and Swiss industry in order to go forward in the future of the manufacturing, and what lesson may eventually be applied interesting for the Grade Bay manufacturing industry. And this will be in the optic or in the idea of a second machine age. First of all, definition. Okay, restructuring and upgrading means how the industry really is changing, has changed, and will change. Then I will give a definition of what is a second machine age. And finally, I will give some indication of how the research on the factory of the future is done presently in our region for physical organization and control of a factory, what makes a factory smart. In the last 150 years, factories have gone from totally manual operation to single worker, fully automated and integrated process. In some cases, we can even say that the factory can keep working and producing product without light. The steam engine has replaced water as the most important source of energy, and not only steam now, but electricity has changed completely the way in which a factory is run. But it's not only the electricity that you can see applied here to the first assembly line for a car manufacturing, you know very well Ford, but it is also one contribution from Ford as an engineer was the standardization of parts. Because standardization of parts means also to be aware of the value of quality in manufacturing produce assembly line. American and European approach to automation is different. The majority of European automation vendors have historically concentrated on discrete and batch distributed automation, some with local controller that we call it a PLC or PAC, Programmable Automation Controller. While many of American vendors have moved towards a highly centralized control system such as DCS, Distributed Control System. When manufacturing cells are independent, distributed components, the control level is very sensible. And we think that the European way to do the automation is more flexible and easier to implement. Increased computing power is also the next step of a factory of the future. Increasing computing power makes manual tasks different. Embedded computer in the plant floor has made manual tasks fewer but much more complicated. Workers not only do the task machines are not capable of performing by themselves, but it is also becoming a worker that is implementing the automation. For example, in the Audi manufacturing plant in Ingolstadt, Germany, the human worker do the installation, the programming and maintenance of a robot that actually built the car. Human worker also do the final assembly of the cabin and the cockpit, where the fit and finish must be carefully performed and visually inspected by a human being after assembly. A modern automated manufacturing plant requires highly trained workers that can perform a variety of sophisticated tasks ranging from programming to troubleshooting to predictive maintenance. The head of Rolls-Royce Manufacturing said, if manufacturing matters, it is important that all the building blocks are taken into consideration. And particularly, we need education for the workers that are in the plant and around the plant. The factory of the future implies more job, but different job. Many people, particularly in Europe, think that automation is killing job, but is true only for certain kind of job. Many workers on the plant floor can be educated in order to better integrate automation with manual plant. Taken together, it is clear why manufacturing in North America is seeing a resurgence. For example, the president of Massachusetts Institute of Technology notes that China manufacturing output is now approximately the same as the United States, but that the United States achieved this with only about 10% of the workforce, in large part due to automation. However, China is moving fast. For example, this is a plant where the tires are assembled and this is a tire mold manufacturing in Zhejiang. So, when we start to talk about factory of the future, we also talk about autonomous control and processes. The factory become in charge. It's not only human, but also machine working together. And when we see what are the jobs coming out of MIT, they are all jobs free or job lights. Machines are smarter. We'll accomplish this with smarter embedded controller, all communicating across a common plant, Ethernet-based backbone, using both wired and wireless communication technology. But also the software is taking a very big jump in performance and ease of use. Easy operation software will improve human behavior and prevent catastrophic failure mode, all leading to the benefits that are shown below. For example, the problem with a non-automated factory is high variance of finished product, poor quality, low throughput, poor worker safety, and large headcount, difficult to reconfigure for changing product, large inventory required. This is not sustainable. Instead, the benefits for the automated factory, it is that it's more flexible, there is a higher throughput, improved quality control, increase safety, and allow workers to focus on very high value tasks. This is much more sustainable. The Internet of Things is also what it enables the factory to go out of its only physical site. These two companies, SAP, that is world-leading enterprise software manufacturer, define the Internet of Things as a world where physical objects are integrated continuously into the information network, and where the physical object can become active participant in business process. Services are available to interact with this smart object over the internet, query and change their state and any information associated with them, taking into account security and privacy issues. One of the seven projects from the EU framework is global network infrastructure linking physical and virtual objects through exploitation of data capture and communication capability. So all these start to become today factory, but more and more strong in the future. If we take all this definition of Internet of Things, as well as other, first, there is an ubiquitous nature of connectivity. Connectivity is everywhere. Second, every object is identified globally around the world. And the third, the ability of each object to send and receive across the internet or private network they are connected into. But what is also very important is wireless. Future is wireless. Nanotechnology is providing new and inexpensive to manufacture sensors that are easily capable of being battery or solar powered, and many of these sensors are going to be wireless. One of the major reasons for using only one or two higher accuracy sensors today is that for each measuring point we can have only one, maximum two. But this is not so reliable. Wireless sensors instead that can be installed in multiple using a matrix array can produce very high precision measurements that are much more accurate than any single sensor. Another coming now strong is the growth of artificial intelligence in automation. Systems will incorporate adaptive learning techniques that in commercial market have led to successful products. In manufacturing it is more complex, but it can be done. This is one of the projects on which we have been working, and the machine, they can from one side measure, you see on the top a wireless self-centering probe, and on the other picture there is the machine, the real machine, that seems to be connected, interface, integrated with a virtual model of a product that is manufactured. The different colors give different degree of precision of a manufacturing product. Towards a new theory of manufacturing automation. You remember at the beginning we talked about also organization. The new factory, they are much more organized and definition, and the definition of a factory is changed. A factory is no longer a location on the map or some building and a fence. It's much more easily described with a complexity of a process that the factory extend and encompass. The factory of future forests must be flexible, complexity with process must be made simple to comprehend and operate using new software and machine intelligence. Slide. Okay. Let's now look at this figure. This figure shows the evolution of the world population and the evolution of social development. On the x-axis is shown the time, and you see that it goes 2000 by 2000 years. And on the right, there is the evolution of how many people are on Earth, and on the left is instead the Human Social Development Index. I will not describe here what it is, it can be found in literature. Now, if you look at the two curves, one for the worldwide human population, right-hand scale, and the one of human social development, left-hand scale, they look going more or less at the same degree. But at a certain point, there is like you see here, at a certain point, these two curves start to go up very sharply. both in terms of population as in terms of human social development. And there is one point where this happened, and it is when Watts engineer developed and introduced the steam engine in 1775. This is considered really the first industrial revolution. So if we look at the industrial revolution that we know quite well, the first one was the steam power. The steam allowed the substitution of human power, and this is considered the first machine age. But then we had, of course, other revolutions, like the one of electricity, that brought a new factory organization, the one of a computer, new factory control, and finally we have now in the process of introducing artificial intelligence. Artificial intelligence is substitution of human brain. This is the second machine age. So we can talk as many industrial revolution we want, but in fact there are two precise moments. One is the first machine age, human power, and the second machine age is human brain. What will be the next industrial revolution? Well, we believe it is sustainable manufacturing. It seems that we are doing that already. No, we are not. Anyway, if we look at this slide, we see at the top there are 4 products. I will not have time to talk about this, but these products are in fact products that have component or technology made in Switzerland. All of them. To have a product, we need to go to the design, manufacturing, and then the manufacturing is divided in physical, control, and organization. Physical is the process, and the organization give the flow. Control the two aspects together in the manufacturing. Now, of course, we are in the age of 3D printing. And 3D printing is one way to go almost directly from the, let's call it design, to the process. But that needs to be understood and controlled very well. My final point is about the frontier research in EU and Switzerland. We are facing 2 big challenges. One is a society that is changing, and the other is mega trends in the technology and organization. Both these aspects are a challenge for manufacturing that bring a key technology, and therefore we need new research priority. We are working on this already for some time in Europe and in Switzerland, but I will only mention here, apart the advanced manufacturing process, the mechatronics, the information communication technology, and the manufacturing strategy, we are concentrating very much in this phase, the modeling, simulation, and forecasting methods and tools. These are key technology that will help the factory of the future implementation. The last one is not the least one, is knowledge worker. We need workers that are able to understand and work in this new automated factory. If we put together this in a very simple diagram, then the green arrow is the product. The product green because of course must be sustainable, social, environmental, economical context. But to produce the product, we need a factory. And the factory is composed by different steps. But anyway, when we design or redesign the factory, mostly we do that on a virtual level, or what we call a digital factory. It's the brown part. From a design, we go to engineering, to ramp up, and finally go to a production where the products are made. In these phases, the digital factory is slowly substituted by the real factory, but in fact they work much together. And in this other representation, we have vertically the product life cycle that go through design, development, engineering, production, and use and service and recycle. On the horizontal axis, instead, we have a factory life cycle, starting from design, engineering, ramp-up, production, and dismiss and reuse. And the light blue is what we call digital factory, and dark blue is the real factory. Of course, we have already many of the tools, and we are using that from sometimes, but new tool needs to be designed and redefined. Why? Because the factory of the future, in fact, is not by himself. Factory of the future is living and integrated in the society. Village, city, shop, other factory, environment, and of course, man. Then the factory is part of a very smart networked world, more and more smart. So there is the factory smartness inside the factory and outside. Outside is Internet of Things, Internet of Brains, Internet of Service, smart products, smart building, and so on. Everything will need to be connected. We are still far to have this. And finally, we have what we explained before, the interaction between the factory and product, digital and real together. We have been working on this for already some times, but there is still a lot of work to be done. This is my last slide, and it is the manufacturing challenge towards environmental sustainability. This we talk already from a long time, but we are still far to be saying that manufacturing is sustainable as we need to be. We need to reduce the consumption of water and other processes. We need to have near zero emission, including noise and vibration in manufacturing process. We need to optimize the exploitation of material in our manufacturing process. And we need to co-evolve product, process, production system in a kind of symbiosis with a minimum need of new resources. And in this figure, you see, indicated by this arrow, we have to have clean energy. We must use clean energy. And the other side, this is a new concept that is coming up, is the community benefit. We can not only talk about our factory without talking about the community around the factory, in the factory, and so on. So you see here the shape, service, byproduct are exchanged, knowledge is shared, and so on. So this is really the future of the factory. It has to be more sustainable, has to have clean energy, has to be integrated in a community. And we are working particularly on the community benefits in terms of energy and other aspects. Thank you very much.